Okay, I'm going to pass around the attendance sheet to get that signed. I spent some time sort of previewing what's going on, and I adjusted our calendar a little bit. Put some if you look on your, I can't look on mine or I would show it to you, but if you look on your Canvas page, like in the calendar, and then our class, I have the assignments for next week, but then I put placeholders in the future where I'll fill in assignments, so you can kind of tell what we're going to be doing, what chapters, when there might be a test, stuff like that. So you might want to check that out. But today, I thought this chapter was a little bit easier since there wasn't any math in it. So speaking of math, since what this class is for is preparing you for architecture in general. Some of you want to go engineering, but as architects, like I said before, you're supposed to understand the principles behind things. We're not really supposed to be able to do calculations and all of that stuff. Sometimes it's good to understand that, to understand what they're trying to teach you. So at least for the foreseeable future, like for the next week's chapters, how I say read the chapter and answer 5 questions. I don't want you to answer the math questions. I want you to choose verbal questions to answer, because those are more theoretical. And if I think we need to go over how to do math, I'll do that in class for now. If you want to do math, if you love math, you can do it, and I can tell you if you get it right or wrong. But yeah, for the ones next week. Today I don't think there was any math questions. But anyway, I want to go over the HVAC delivery systems. That's our topic for today. Thank you. And why don't we leave that back there in case people come late. Okay, so it talks about the different types of systems, options available from a single package unit to central plants that cover your whole building. It talks about work by one or a combination of how they work by one or a combination of principles. You vary the temperature and or the quantity of the air supplied to the space, so that's the way you can control the HVAC system. You can set your thermostat for a certain temperature, and then it will control that temperature, or it'll blow more air in. I mean, we read through different ways. Section 3.2 and 3.3 talked about zones. Zoning is important. For instance, this room, since I don't know if there's another room attached to that thermostat or not, but maybe an easier example is your house. If you have a 2-story house, or if you have a large house, you might have different zones. The top floor if you have 2 air conditioners, the top floor may be in a zone with 1 air conditioner, and the bottom floor in another. There's multiple rooms in those zones, but do you understand the difference there between a room is not necessarily a zone. It can be part of a larger zone. Does that make sense? And sometimes it can be more efficient that way. I design homes, a lot of homes on the island that are more like vacation homes, or they're for older people that don't have their children living with them anymore. So they have a zone, which is their primary living area, their bedroom, their living room, their kitchen. That one runs all the time. But then they have another zone where there's guest rooms, or for when the children come. And that one they can just leave, in the summer they can set it on 80 until someone comes visits, and then they can put it down at 75. So it saves them some money. It's a money-saving system. And then we're going to talk about the different units. But I thought the diagrams in this particular one were pretty good. Talks about, well, this first one was about the air terminals. I had a hard time seeing what these meant at first until you're actually looking at a section view. Everybody know what a section is? When you slice, like you're slicing vertically through this room. So you're slicing through this wall, and there's a window you're slicing through. This is the floor right here. Does my mouse pointing? Can you see that?
Yes.
Okay. And this is a ceiling. So sometimes you have air terminals at the sill line below the window. Sometimes you have them suspended from the ceiling. Sometimes, or that's this one down here. And sometimes you have them concealed or in a soffit. Sometimes you'll see step downs in a ceiling, and usually there's ductwork running in there. And sometimes, like this particular one, this is a furred down ceiling. The structure, which would be this dark gray line, is above, and this thin line is what we see right here, which is the acoustical tile. If you lifted one of those panels up, you'd see all kinds of ductworks and wires and stuff all over the place. So that's what this room we're in right now is like D. That just talks about the controls, the hierarchy of the controls, sensors and actuators and stuff. And that's I'm sorry. So when you're talking about the control system, you want to know what is it you're trying to control. How do we measure the variable it is that we're trying to control? For instance, temperature. How do you measure that? And then how do you control it? So we have a thermostat back there. What is that measuring? The room temperature. And what's it set on, Ariel?
Set on 72.2.
So hopefully that temperature has a little switch in it, or that thermostat has a little switch in it, and when it gets too far off, I mean, it won't, like as soon as it gets to 72.3, it won't click on. It has a range. Probably when it gets to 70, huh? Oh. So, sorry. When it gets to it has some sort of range in it, maybe 5 degrees or something, maybe not that much. But then when it hits that, it'll click on, and the air will come down, and then it'll probably dip below that temperature for a little bit, and then and then it'll stop for a while, and then it'll click back on. So that would be the thermostat controlling the temperature. If you want to control your humidity, that might be another way to control, another switch in the system. That there would be a sensor somewhere that would measure the humidity in the air, and it would send the signal to turn on the heater, which would dry out the air and decrease the humidity if it was too high, or if you needed more humidity, you'd probably turn on something else to make more humidity. So then that switch would then go on to the equipment and turn it on. I'm getting lost. Okay. So this just talks about the different air handling hot water coils and how that might work. But what I wanted to get to was okay, this is a single zone system. This would be kind of like what's in a single house if you just had a single zone. And what this means is you've got your outside air coming in somewhere. Everything has to have outside air. Then you've got a heating unit or heating coil and a cooling coil. So the air is going to blow over that. This thermostat down here sends the signal to which one of these it needs, either hot or cold. And usually on a home thermostat, you can't have both at the same time. It's either on heat or cool. You have to have a pretty complicated system to be able to mix those two. And that's usually only done in commercial. So in your home thermostat, you know, if you have it on cool, when it dips down to, or when it gets up to 75 and you have it on 72, this may click on. The air would blow over that cooling coil and then out this way to different rooms. These are different rooms you're looking at here. And see, that thermostat's in one room, but it's also blowing into this room. So your air is either on or off. So when it's on, you got 100% airflow. This is the temperature range that you could probably have. You know, up to like 100. You could the heating coil would go up to 125. Your air wouldn't necessarily get that hot, and your cooling coil would be at around 50 degrees. So the air blowing over that would cool off. So that's a single zone constant air system. That didn't go down. It's just a look at one of those things. And then a constant volume dual duct system. I mean, it went through all of these in pretty great detail, but this shows you how you would have 2 ducts and then a mixing area where the thermostat in this room would control how this mixes the air from the hot duct and the cold duct. And you have a thermostat in this room that does the same thing. In the constant volume multi-zone system, sort of the same thing. You got 3 different ducts coming out of the hot terminal and the cold terminal. I mean, y'all have all these. You can study them. Single zone variable air volume system. Do you understand what all these pictures mean? Is there any questions on, you don't understand? Okay, like I said, this is kind of like a section view. You got your outside air coming in to your air handler unit. You've got, in this one you have a cooling coil. And this thermostat here inside the duct in this situation controls the cooling coil. So the outside air blows over that. Then you've got the damper, which can control the airspeed. So you can have a different, like if you don't like a drafty area, you can close that damper off and it won't blow so hard. So that's how they would control the temperature in this room, because this only has cooling in this particular system. So the only way you can warm up is just to turn this down or off so that the damper shuts and then no air blows out. And then this is the return air. It goes back to the system, mixes with some more outside air, and comes back through again. So in this one, you have very little heating. You got a lot of cooling. And then, you know, for your airflow. And then you have the temperature is basically the same in this cooling thing. There's no heating element to make a warm air. Does that make sense? Okay. That's just the equipment used in that. Multi-zone variable air volume system. This one does have heating and cooling. So this one you can control your airflow again with these dampers. And you have heating and cooling at 50 degrees, I guess it is. The air blows over that. This thermostat controls how that works, and then it comes out this way. And the damper controls the airflow. Sometimes you have if you have those systems that only have cooling systems, you might need heat every now and then on the exterior of your building. It talked about that in the chapter, because typically an office building won't need a lot of heat, especially in our climate. The buildings downtown, for instance, that are tall buildings, or even maybe this building doesn't use a lot of heat, except maybe this weekend when it's 40 degrees constantly. But this room may never have the heat on. But the offices that have windows might need heat because of the radiation from the outside. So in that case, you would put these convector installed base perimeters, whatever, around the edge. The trouble with those is you can't push the furniture up to them. You have that, makes an awkward gap sometimes. But that's what that might, a cutaway view of the hot water convector system. So I'm not going to go in to all of those. And the another system is the variable air volume reheat system. That was an interesting system because you take the air, you cool it, and then you reheat it. It's kind of wasteful. It's one of the most expensive systems, but sometimes you need it for different reasons. If you need to control the humidity but have cool air at the same time, you have to use this system. So that has airflow and heating in it, and then the thermostat here, and then you have a damper, and then you have over here, you heat it up again because you're controlling the relative humidity, or the reheat coil. That's what it is. Just another dual duct system with variable air volume. There's a multi-zone variable air volume. That just means there's a damper system in there that controls the amount of air. You got fan terminal units, which may be, those take up room in each individual zone or space. So you have to have a lot of ceiling space for that to work it that way. Just trying to see if I want to highlight anything. Radiant panels, that's used a lot in like the arid climates. What?
Oh, like warehouses and whatnot?
Well, maybe, but I'm thinking more of like Arizona or California, where the air is typically perfect and dry. So, but it might be cool in the morning, so all you need is a little bit of radiant heat to warm up, and then it'll stay fine. You don't really need a lot during the day. I've never used these chilled beams. Those look kind of expensive. But, the PTAC is like what you might see in a hotel. Or a house. If you have a window unit, that's a typical PTAC unit. They're loud and noisy, and
Only one room in your house has one.
yep. So, but sometimes you need them. Sometimes they're good. Dedicated outside air systems with air ducted directly to the occupied spaces. It's another one that, oops, that's the end of that. Okay. So, I guess what I wanted to do too was focus a little bit on, is there any questions on the controls? Because that's an important, as architects, we want to understand how to organize our buildings with, to help out with the zones of the air conditioning and the heating and the controls. We have to understand that terminology. So they talked about, the zones and controls. Y'all have any questions about that? Do you understand it? If you don't ask me questions, I can't answer you. So you can control the temperature, the pressure, the flow rate, the humidity, the speed, and the time. Those are the things you can control. And you understand zones. That's important. Everybody understand zones? Okay. All right. So what are your control devices? Tell me a control device. Nobody knows a control device. A thermostat is a thermostat is the one we're most familiar with. Dampers.
Pressure, the flow rate,
Mm-hmm.
humidity, speed, and time.
You have switches for those. Yes. Control valves. What is an actuator?
They provide physical control of the equipment, typically dampers and valves.
You reading that? It provides the physical control of the equipment, typically dampers and valves. You got that right. Okay. So you got to understand that and, you know, the different elements of it. So if we're trying to control the humidity, how do you measure that and how do you control it? If we need a really dry room for some reason, like we store paper there and we don't want it to get all wobbly, how would you control that?
The humidistat.
The humidistat, yeah. And then that would, you'd probably have one of those systems that has to reheat the air if you really cared about the paper. If it was like precious gold paper. But in your typical office supply room or whatever, like if you have a room full of paper, or like we have a room downstairs that has a big copy machine of paper, we use it so fast that it probably wouldn't get wobbly. But you would want that to be, and you got to take into account too, there's a big machine in there that produces heat that dries the air. So that's automatically got some drying effect in there. So the engineer generally knows that, and that probably takes up enough, or reduces the humidity enough in that room. So if you wanted to, what else can we sense and control besides humidity and temperature? How would you control if you don't like it breezy? Airflow. How would you control that? With the damper. That's right. A damper system. So your thermostat could be triggered that the dampers open and shut according to the temperature. So, okay. So what kind of system would you have typically in a one-story house? A single zone. Starting on page 77, it starts listing all those systems. A single zone reheat? No, I don't think you'd have that. Unless you, huh? Just a constant temperature. Variable, or single zone constant air volume is probably what you'd have. And why do you think you'd have that?
Simple, it's convenient.
Simple and convenient, easy to use. And that's what, I mean, most houses you don't want some computerized, you know, system. You need a mainframe to run. So what would you have? What might you have in a house in Arizona? What do you think you'd need? In Arizona, where it's desert climate, but it's cool, dry. These are questions I made up. But but you can look at the different systems and see what you might have.
Single zone?
What?
Single zone?
Like we just talked about?
Yeah.
Yeah, but say you really don't need the air conditioning part of it. What would you have? Not the reheat, I don't think. You don't need a humidifier because it's so dry. What? Well, you can have a little humidifier in there. So what would you have? Because all you might need is heat every now and then. What would you use? Hmm?
The constant volume. Cool.
No, I don't think you'd need a. Well, I mean, I guess you could have the air conditioner. The, yeah, you might need to add humidity to it, actually. But I was thinking more along to the radiant heating and cooling because the air is always perfect. So all you need is the heating element or the cooling element. That's how I think I would like it. But there's no right or wrong answer. I just want to know why y'all think. I want y'all to think about it. Yeah, like radiant heating and cooling. That or just radiant heating mainly. I mean, you could probably. Okay. I guess I'm thinking of Arizona in the mountains. Not Arizona in the desert. All right, let's move on then. What about a hotel? What would you use? You could have well, you probably have a bunch of different elements in a real hotel because there's public spaces and.
Which one, you want the rooms or the hotel halls?
Yeah, the rooms. What would you have?
Probably that single air unit that goes right underneath the window.
The PTAC. You could have that. I've seen that a lot. But if you're in a brand new, like a high-rise hotel, you probably would have the multi-zone thing, where you can control, where you have a digital controller that would sense whether that room. I mean, when somebody checks in, it goes doo-doo-doo-doo, and turns on the air conditioner. So by the time you get up to the 30th floor, it's cooled off. So, in a nice hotel.
What if you were at like Easy 8 Motel?
If you're at the Sleazy 8 Motel, you probably have a PTAC unit.
You probably have a rotating fan.
So- and it'd probably be all moldy in there. And so- that's what most motels have, like the Sleazy 8 and the. So, what about what do you think you'd put in not this type of school, because this is really a business, but in a school like a high school or any K through 12 type school, what would you put in there?
Don't they control them by floors?
Don't they what?
Don't they control them by floors? I don't think they want to have a thermostat in every room.
It depends.
So don't they don't want the students messing with it. Normally.
Yeah, well, they could put a lock on it.
What, a triple deck?
A triple deck.
Triple deck multi-zone unit?
Why do you say that? Defend your answer. It's not. I'm not saying it's wrong. I just want to know why.
Control the different zoning areas. You know, the gym may be a little bit more cooler, a little more activity than the cafeteria was. Some floors generate more heat than others. Most high schools are multi-level anyway.
Well, they're like at least 2 stories, I guess. What page is that one on? Just so I can look at it.
That'd be on page 83.
83.
Yeah, it's sheet 3.4.
Page 83. Ah, there it is. Constant volume multi-zone system, a triple zone, double deck multi-zone. So you can control, you have different zones and you can control them by mixing the air. Or no, it's just hot. Oh, it's hot and cold. Yeah, you mix the air. So,
It bypasses over both coils.
right. That can be more expensive because you're heating and cooling at the same time, but sometimes it's good because that's what you need.
A lot of schools with some pretty big units. And I know Miller uses what, a water cooled unit?
Yeah, I think that's the one toward the end, where you have like the water towers.
Yes, sir.
That's what they were talking about at the end of the chapter, I think. If I remember right. Dedicated outside air systems.
Yeah, that's what it is.
I grew up in Houston, and we used to ride our bikes during the summer all over town. And we would always find those water towers and go rest by them because they were cool. So, it- a lot of hospitals might use the water tower system too, I think.
But this is strictly dedicated outside air. Instead of recycling air units.
Yeah, the air flows over those.
It doesn't recycle this air either, it's just dedicated air systems.
Mm-hmm. So you don't think you'd use that?
Yeah, we probably. They would have separate units, obviously, for specified areas.
Mm-hmm.
This is for education buildings, high occupancy spaces, classrooms, and conference rooms.
What about jail?
Water from the sink.
You'd have one control in the.
It'd be a dedicated
Bubba.
system. Actually, man, it's freaking cold. I was in a holding cell once.
Oh, you are. Tell us about it
I
now.
asked the police officer for the badge number because he was giving me the lip. And threw me in the holding cell.
Did you notice what kind of air system it was?
I was really cold.
Sat
Sat on the floor.
I would think you. I mean, of course, I'm a.
Well, I don't know. I guess it would be different if it's a police station.
Well, yeah, you want the cops to be comfortable, but not the prisoners.
I don't know, outside air.
I'd probably want a lot of outside air because I think those people would stink. But I wouldn't want them to be.
Bathe every day.
I wouldn't want them to be too comfortable.
They're supposed to be.
I mean, they're not going to on vacation. So.
If they get cable TV and other things. I'm sure they got free with AC.
I think I'd want the most economical system.
How much does it cost?
I don't know what they cost, but I'd want something that's pretty economical, you know, that they can survive in, but it's not like, you know, they don't get to sleep under the quilty blankets at 68 degrees every night. So,
Did you get the fan that sucks up all the air out of the restroom and just reverse it?
What about a grocery store? What do you need in there?
Something pretty cool. They can cool down like a very big area.
Yeah, it's usually cold in grocery stores
Say single zone breathing.
because and you also probably have to control the humidity a lot because they got all those showers all over the vegetables. So that makes.
Okay, constant volume general reheat with multiple zones.
So the point is, you have to know what you need, and then you got to look through these systems with the help of your engineer, of course. And you got to understand what the systems would do, and then you got to know how much space it's going to take, and what, so you can design appropriately.
So when all is said and done,
What?
at some point they're making a guess
Mm-hmm.
comparison, and it's not necessarily the best, it's the most efficient in their estimation at the time. Correct?
Yeah, and sometimes, like the variable air volume systems are more expensive to install. There's more equipment in that. So you may want to put that in, your office or whatever it is you're designing, but the client may say, no, I don't care. Let them sweat. So, you know, I just wanted to just, you know, put in whatever's cheapest and I'll hear the complaints. But I mean, the engineer generally, at least in my experience, will try to put in the Cadillac, and then you got to talk them down, because I mean they don't get a commission or anything.
They don't go like a happy medium.
Well, it depends on the engineer, but you know they want to design the hottest, greatest thing, because that's what excites them. But
They want them to be more satisfied too.
yeah, the client would be satisfied. Yeah, and they, you know, it's like as an architect, you want to design the snazziest building, and so typically, like if I do houses, I'll tell the client, well, let's shoot for the moon first, and then we can start chopping. So, we usually have to chop a lot. So that's the same, you know, engineers love, or mechanical engineers love their HVAC systems, so they want to get the newest and greatest thing out there, and they'll try to sell you on it. But then you can't afford it, so you got to go back to the old PTAC.
Once your building who does all the heating energy and cost evaluations, like, right, to consider evaluating like the kind of insulation the building's going to have, what kind of building it is.
Who does that after you build it or before you build it?
As in the process.
The engineers and the architects, they all work together, because the architects will spec the insulation in the building materials, and the engineer needs to know that so that they can know, you know, the rating, the R values of the walls and the U values and all that stuff, and they can design a system, the most economical system within that. So you kind of work together through the whole thing.
Because I know in chapter 2, for one of the problems, they actually did a total air conditioning or air cooling load.
Mm-hmm.
And it was all like mathematical gains from like north, south, east, and west for the windows.
Yeah.
It's all calculated together.
But they have computers that actually do all that much faster. So, in fact, there was a disclaimer. I think I told them last time that whatever you learn in this class, don't go out and try to design a system, because this is the simple stuff. So, this is just so you can understand it. It's not so you can actually do it. So. So, if you want to do it, you have to go to air conditioning school. So. Okay, so let's look at some of the questions. Did y'all have any that you didn't? I haven't looked at what you've submitted yet, but that you want to know, that you had a concern with? What? Shook your head.
Let me see. Just like 3.5, 3.6, and 3.7, like which HVAC system is best for preventing high humidity in spaces and why?
Okay.
Generally, which delivery system is generally avoided because of high energy usage?
Let's take them in order. So 3.5 is which HVAC delivery system is best for preventing high humidity in spaces and why? Does anybody think they have an answer? Question 3.5. You want to prevent, how do you prevent high humidity? What takes the humidity out of the air?
Cooling it down?
Heating it up. Raising the temperature. So what kind of system, delivery system, would do that? A reheating system, that's right. So a HVAC system which cool air and then reheats it are the best for that. Does that make sense? Okay. And then the next one was 3.6. He had a question. Which HVAC system delivery systems are generally avoided due to high energy usages? I think those can save money.
After those systems waste energy because they make warm and cold.
The key is the warm and the cold air.
So,
It's not the zoning. It's the key is the warm and the cold air. So if you heat and cool the air, you're wasting energy. But sometimes you need to do that if you need the low humidity. So you got to figure out what it is you like more. You want to waste energy or you want low humidity? So, or that's the same thing. You want to save energy or do you want low humidity? And 3.7 you said? Was that one too? Which HVAC delivery system are the most energy efficient and why?
Single zone variable air volumes. Yeah.
Single zone variable air volumes. Why do you think they're efficient?
I think go for it.
I'm sorry, go ahead.
Go ahead.
I would imagine just because it's a thermostat that trips it on and trips it off, so it can kind of control itself.
Control by thermostat and dampers.
Well, let's say, I mean, you would use that in
Like a house.
a house. So let's say it's an office building. What would be the most energy efficient?
Variable air fuel duct terminal.
Well, the variable air valve, or VAV system, is the most energy efficient because the fan only works when it's needed, and that's what sucks up the energy. So no matter how many zones you have, it's probably one of the most efficient types of systems in general.
So just VAV system.
Mm-hmm. What other questions?
When is it appropriate to use a two-position control?
When is it appropriate to use a two-position control? That's 3.12. When is it appropriate to use a two-position control? What is a two-position control? First of all.
they start with the close the control equipment.
They start, open, and close the control equipment? So if it only stops and starts the airflow or the system, you know, it's just like either on or off, basically, right? So when would you use that? That's like I'm trying to think of where there's one of those. Can't think of one at the moment. But you wouldn't want it to be a place like this, I don't think, because we wouldn't want the temperature to drop down to 60 and then go up to 80 and drop back and forth. We want it more even. So you wouldn't use a two-position control when you don't want large variations in temperature, because it's either on or off. And you know, a modulating system is better when you want to control, when you want to keep it more at an even keel.
I guess it'd be appropriate in like a freezer of some sort, like a big old storage freezer.
Yeah, but that would just be on all the time. So, I know I'm trying to think of where you might have that. Maybe in a warehouse or something.
I was thinking that too, but I've been saying warehouse too many times.
Like a conditioned storage place or something where, you know, nobody's in there, so it's just you got to keep your stuff between 70 and 80, or something like that. And so you can turn it on when it's 80 and turn it off when it's 70.
You can turn it off at night.
Yeah.
Turn it on during the day.
Yes.
Keep it off at night.
Small offices, medical buildings, stuff that have open doors continuously.
Mm-hmm.
Why wouldn't a system, like, market or something like that be used for front doors are always open, like HEB, wouldn't that be a two-position, right? Because it needs to control flow, it needs to control temperature, that's constantly changing. You can't have it click on and off, on and off, on and off all the time to control it. You need to control flow and temperature at the same time.
So what are you saying? HEB should have that?
Yeah, that's what I'm saying, like big markets like that would have two. The question asked, when would it be appropriate to use a two-position system?
I don't think HEB would be appropriate. I mean, it might be appropriate. I mean, if you
Okay.
ever walk through those doors, they have the air shields.
Yeah, but that, when the door opens and then like the air comes hitting your
Yeah.
face or something,
Blows your-
would that be considered, would that be considered a two-position?
That in the
In that little
specific thing is
locking
maybe,
area?
yeah, that's on and off.
Yeah.
But the whole control system for the HVAC of the whole store is not.
I wouldn't say that they're not ran by just one system, no. In a big building like that, we have multiple systems.
Probably in different, like, it probably has a different, yeah, like over in the produce where, yeah.
Well, in the
The
vestibule.
first 8 feet, maybe. I don't know.
But like that switch over when the door opens, that thing blows down.
Well, yeah, I know they
In
have
the-
those now, but not all stores have those. Some of the older HVAC stores.
Yeah, that's true.
slide in.
And that's why in that other class we're doing, we have a vestibule. That's to control the air, so it doesn't all escape. See, it's all connected. Let's see, what else?
How about 3.15?
3.15. You're helping an owner to decide on systems for his new office building. For perimeter offices, he will use either a VAV reheat or a VAV with perimeter convectors. His contractor will provide either system for the same cost. How would you counsel him on matters of cost and quality? Any ideas? What is the VAV with perimeter convectors? Those are like the radiant heaters on the baseboards. What's the problem with those, architecturally speaking?
Constant energy?
Architecturally speaking.
Oh, sorry. Ugly?
Ugly, yeah. They might get in the way of furniture.
They're hard to place,
Yeah. Right. So that's I mean, if space is an issue, you know, that's going to take 3 inches out of your room. You can't cram a desk into the corner or something like that without you're going to lose 3 inches of space. But the other system, the reheat system, runs up there, and there's piping with water sometimes. So what might happen there? Is it ever good to have water in your ceiling?
No.
BAS system, right? Building automated system?
What'd you say?
Building automated systems, you didn't use like the EMCS? You didn't use
I don't recall it. That's not what it's asking us. We're choosing between a VAV reheat and a VAV with perimeter. So the reheat system,
What I'm asking, that reheat system is considered a building automated system, right?
I guess it can be, yeah. But it has piping. That's the trouble, I think. And valves in the ceiling, things that could bust and cause damage and throw water everywhere. I never like water in my ceiling. So, but I also don't like ugly heaters on the floor. So I guess
Just ban on your
just point and shoot, whichever one you want. But so I guess
You just, I guess, let the owner know
Yeah, you let them know
what he prefers.
the issues, and then if they say, well, I'd rather have, you know, less maintenance up overhead and have a little less floor space, and that's what I'll do. Or I'd rather take a chance and I'll keep an eye on it. Not.
I think I would.
So, okay. But how about 3.17? Why would you recommend the extra construction cost as the architect? Why would you recommend that for a four pipe fan coil system versus a two pipe fan coil system?
Who's the air factor?
Mm,
Because overall, in the long run, it would reduce energy costs by running the AC system in shorter time frames than longer time frames.
well, the difference in the two of them is that
The 4-pipe fan coil system over the 2-pipe fan coil system.
The 4-pipe is more flexible.
right, it's more flexible because it can run hot and cold at the same time. Two pipe can only do hot or cold. So if you wanted a more flexible system, you'd recommend the extra construction costs for the Cadillac.
What's wrong with Honda?
What question was that?
That was 3.17. Anything else?
What is the primary energy advantage of using radiant cooling?
What is the primary energy advantage of radiating? Oh, that's 3.18.
It reduces fan power.
Yeah, exactly. Because you don't have to use fans, which suck energy. But sometimes you need airflow, depending on your building, it may be good or it may be bad.
What about 3.19?
I was looking at that. Because heat pumps are, it's hard for me to get that, understand that, but does everybody understand what heat pumps are? How they work? Most of our systems in our homes around here have heat pumps because we don't use heat very much. So it can all be combined in one unit. But the question is, how are water source heat pumps and PTAC units similar, and how are they different?
They're similar, but they can operate both heating and cooling.
Yeah. They both have compressors in their unit. They differ in their means of rejecting the heat. The heat pump pumps the heat out. The heat pump rejects the heat to the water delivered by a piping system, and the PTAC rejects to the outdoor, so it just pushes it out through the air-cooled condenser. The PTAC must be located on an outside wall, or a rooftop, so it can't be in the middle of the building somewhere. What? Who said that?
Sorry, I was reading.
Oh. Heat pumps can be located in the ceiling or other locations.
They need the outside air.
Right, they just have to have the piping. So.
It says here that the PTAC, it can be operated in reverse refrigeration like a heat pump can.
Yeah, it can.
Awesome.
That's how, since, I mean, if you have a heavy load for heating, like up north, you can't use a heat pump system. It's not very efficient. But here, since we don't use heat that much, we can use it, and it doesn't cost that much. Up north, you have to use oil or stuff in a real furnace that boils water and heats the air. So. But you'll be needing one of those tomorrow.
Oh, yeah.
It's going to be 45, raining. Probably already cold.
Now it's
I forgot to bring a coat. So when I go home, my car has heaters in the seat. What kind of heat is that? Radiant, that's right. And I'm going to turn it on as soon as I get in the
You
car.
got remote start?
I wish. So-
I hate that commercial where families flying on the airplane and their car's covered in snow. And the guy turns it on from his phone. The Cadillac.
I'd be worried somebody else could wire and turn on my car.
No, if it's on the car, does that necessarily mean that it unlocks it?
Yeah, I
It
don't
doesn't
know.
lock it right.
I think so. I don't know.
So why would you want to turn on your car if you're just getting?
No, if you have a remote start, you don't unlock the doors, it just starts the car.
Oh, okay.
And then you get near the car and it unlocks.
Gotcha. Okay.
All right.
Just don't get remote start for standard car.
Now I'm cold and hungry, so. Okay, we're gonna, next week we'll be doing chapters 4 and 5. And you'll answer non-math questions. Then the week after, we're gonna go through all of HVAC before we have a test on HVAC. So we're not supposed to have a test until like 2 weeks. Okay? Any other questions? All right. See you on the flip side.